the iron concentration as 0.010. We have the cobalt concentration, 0.5. Okay? We want to find out, and again, I'm going to get rid of something on there. We're going to find E, not E0. Okay, instead of finding E0, we're going to find E. Now why? Because it's not standard. And the only time you can find E0 is if you have a standard cell. And with standard cell, everything is 1 molar. Since this is not 1 molar, it's not a standard cell, you figure out E, not E0. And to figure out E, we use the Nernst equation, which says E equals E0, okay, E0, minus 0.0257 over N times natural log Q. Okay? All right. Step 1, let's find what E0 is. To find E0, I'm going to take my oxidation and my reduction. The oxidation is the iron, Fe, going to Fe plus 2 electrons. The reduction is the cobalt plus 2, gaining 2 electrons, giving us cobalt. Okay? Cobalt's my reduction, so I'm going to look it up. I get a negative 0.277. The iron is my oxidation, so I'm going to try to find the iron and reverse it. And if I do, I see that the iron is a minus 0.44, so I'm going to reverse that and make it plus 0.44. And then add them together. Comes out to 0.163 positive. I get a positive 0.163 volts. That's my E0. So now I go back here. E is going to equal E0, which is 0.163 volts, right? Negative minus 0.0257 over number of moles of electrons. I'm not going to see how many change. According to my equation, the iron changes 2, the cobalt changes 2, 2 electron change. Okay, either way you go, it's going to be a 2 electron change, so we're going to divide by 2. Times the natural log of Q, which is right to left, which is iron over cobalt. Iron, 0.01, cobalt, 0.5. Okay? So, let's see, this is going to equal 0.163. Let me evaluate this whole mess here. I'll do the natural log first. I'll start from the right, work my way backwards. So I'm going to take 0.01 divided by 0.5, and that gives me 0.02. I'm going to take the natural log of that, which is minus 3.91. I'm going to multiply that by 0.0257, divide by 2, and this whole mess becomes 0.050. Negative. Okay? And there's my voltage for the cell. What I did here is I worked backwards. I took the 0.01 divided by 0.5, I got a number. I took the natural log of that number. I multiplied by 0.0257 divided by 2. Worked my way backwards until I got this. Then I take this minus this, gives me that. Nernst equation. Use the Nernst equation when you do not have standard cells. Standard cells would be where everything is 1 molar. In this case, everything is not 1 molar. You've got one thing that's 0.4 molar. We've got one thing that's 0.01 molar, the other thing that's 0.5 molar. Okay? All right, good enough. Like I said, up here you got another exam to practice with. It's a little better in quality. Take it, look at it, and this way, you can see it. I will answer questions on email, but I will not answer what are all of the answers to the problems. If you ask me that, I'm going to ignore you. Okay? But if you go through this and you happen to have a question over one of them, say, I don't understand number 6, I'll explain it.